Hi everyone, this is Rajkumar. Last video we have seen what is data type and what are all different data types available in Java. This video we are going to see what are all possible literals available in Java respective each data type. Along with we will also see type conversion. Okay. First of all, what we have seen before is like we splitted a data and whatever the possible data we splitted in two category. One is numeric data and non-numeric data. Inside numeric, we have seen this as non-decimal and decimal value. We told the whole number is non-decimal and the number with decimal points and with precision, right? That is called decimal number. This is what we mentioned in the last video. And this video, to understand and something, I just rephrase this one. Instead of call this as decimal, we can call this as floating point number. Okay, so we again split the numeric value in two different category. One is floating point number and other one is non-floating point number, like this. Okay, so floating point number, in the number itself we have a dot as a separator, and before dot is a whole number, and after dot whatever it's coming is a precision value. Okay, so non-floating point number, it doesn't have dot or like a precision value, only it will have a whole number. Example, 5 is non-floating point number, 5.5 is floating point number. Okay, so we already know the default of non-floating point number. If we are giving anything, Java compiler will consider this as integer. And similarly, floating point number, if you are giving anything, Java compiler default will consider as a double. Okay, now when we talk about number system, we have classify the number system in four category. How we can represent, like we can classify number system based on representation in four category. You would have already know this. If not, let me know. I will have a separate session to explain that. So understand this now. First one is binary. Binary will have all zeros and ones. Okay. And second one is octal. Octal will have the number representation from 0 to 7. So the base value of binary is 2 because the representation can be achieved with two numbers 0 and 1. That's why the base value of binary is 2. And base value of octal is 8 because it can be represented with value from 0 to 7. It is actually 8 numbers with 8 individual value. We can able to represent octal, right? That is why the base value of octal is 8. And decimal, everyone know what is decimal. The base value of decimal is 10. It's nothing but like we can represent each and every digit between 0 to 9. Okay, so since it has a 10 number to represent for single digit, that is why the decimal usually like we call base 10 and like it's commonly used representation. Okay, the next one is hexadecimal. Hexadecimal can be represented with 0 to 9 along with A, B, C, D, E, F. Okay, so how many possible value we can represent? From 0 to 15, right? 0 to 15 can be represented in a single digit. So 0 to 15 means possible value is 16 numbers for single digit. So base for hexadecimal is 16. So this case, single digit means it should have a single digit, right? So 0 to 9, yeah, it's actually a single digit I can easily represent. But 10, 11, 12, 13, 14, if you think about in decimal perspective, it's not a single digit, it's two digit. When we look at 10 is two digit, obviously, right? That is why hexadecimal, like we have representation for 10, 11, 12, 13, 14 and 15. So that is A, B, C, D, E, F respectively. Okay, so that is why we can represent 0 to 15 in a single digit in hexadecimal, but this will be represented as 0 to 9 as a number. Then 10, 11, 12, 13, 14, 15 will be represented as A, B, C, D, E, F. Okay, so hope we understand what are all four different representations available in number system. This what like we are going to use it whole when we try to represent a whole number. Okay, based on user convenient we can change it. Consider like I have number A as 5. ASY. This can be integer, this can be byte, this can be short, or this can be long, whatever, because the 5 is in the range of everything, right? So we can keep whatever. Okay, so now since it's a decimal value, I am keeping this as decimal value. It's simple, like I can, it's what commonly used one, right? We can see if we are giving integer a is equal to 5, the response what we are getting is 5, right? This is decimal base 10 format. Okay, if I want to represent 5 in binary, how I can represent? First of all, what is the binary value of 5? This is the binary value of 5. But if I keep it like that, how Java compiler will understand it is 101 or binary 101? Do I need to represent this as, do I need to store this as 5 or 101? Java compiler, how it will understand? Okay, first let's run this. See, like it's storing this as 101, meaning 101, it is storing as 101 and keeping it in the Java memory. Okay, but exactly what we want to inform Java compiler is, like I want to store 5 but I am representing in the form of binary. Okay, if we add a prefix as 0b, we will inform Java compiler that this is actually a binary, you need to consider this as binary and store it in your memory. That is how, like we need to, that is how, like we are informing Java compiler if you are giving 0b. Okay, what will happen, we'll see. See, like we have given this as 0b, so Java compiler will consider this as a binary and it will store it in the memory as a binary, because whatever we are giving, everything will be converted as a binary and store it in a computer system, that we already know, right? But when we retrieve, right, when we retrieve, everything will be converted into decimal and that will be given, because decimal is commonly used representation. That is why Java will convert that from binary to decimal, give it to display. Okay, now if I want to represent some value as octal. Okay, we know what is octal, right? Octal single digit can have 0 to 7. Okay, I want to store 8 as the value. So basically binary of 8 is, what is the binary of 8? 1,000. This is what binary of 8, right? First we'll run this. Okay, this is 8, right? Like how we can convert this as in octal. It's very simple, 3 bit. So basically binary, each and every 3 bits will be splitted and each 3 bits will represent single digit in octal. Okay, so here last 3 bits is 0, so we will consider this as 0, and first uh, first 3 bits is 1, so 10. Okay, so I am not going to represent this as binary, I am going to keep it as octal. So what will happen if I want to represent this in octal? We need to add 0 prefix. 0 as a prefix if we add, Java compiler will consider this as octal value and store it in computer system as binary. Then when we try to retrieve it, like it will retrieve it in decimal format. Like let's see what is happening. Since we have given 0 as a prefix, Java compiler will consider this as octal value and store it in computer system as binary. And when we try to retrieve it, what is the binary value of that what it stored, it will be converted into decimal and display. So here 10 for octal value, what is the decimal value is 8. Okay, that is why we are getting 8. Okay, same way how we can represent hexadecimal, be your question, right? For hexadecimal, like we need to use 0x, how we have used 0b for representing binary. Hexadecimal we need to use 0x. Okay, if we use 0x10, what will be the value for hexadecimal? Hexadecimal 0x10 is 16. Okay, we'll see. Yeah. Okay, so what it is doing is just 0x we have as a prefix, so it is considered, Java compiler consider this as hexadecimal and convert this into binary and store it in computer system. Then when it retrieve, it will be converted as decimal and that's what it is given in a display. Okay, hope we are clear how to represent binary, hexadecimal, decimal, and octal in Java. Okay, consider I am going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I want to read what is the value, yeah, it'll take some time, right? Like what I will do is like 789, then 45,000, sorry, 56,789, then 34 lakhs 56,789, 12 crore 34 lakhs 56,789. That is how like I will read. It will take time to read, right? Like it is having a readability issue. That is why Java giving us own provision. What is the provision it is giving is, okay, I can use underscore in between this number to differentiate the digit. Like is it actually 100 place, or it is in 1000 place, or it is in like lakhs or crores. I can differentiate how I want, like I can differentiate with the underscore separation. Okay, so this way, like it is very easy for me to tell that it's actually 12 crore 34 lakhs 56,789. It is very simple and easy for me to read, right? That is why Java giving this privilege to programmer. Okay, first we will check that it is working or not. Hey, it is working, right? It is storing us 12 crore 34 lakhs 56,789. But is it storing with underscore? No, right? Like it won't store this with underscore, because underscore being used for readability purpose alone, not it won't store this in a computer system. Okay, you can have another question in your mind. I can understand, like okay, consider like if I'm not in India, if I'm in some other country, the representation of number is different, right? Do I need to stick on to this, or how it will be your question, right? Like okay, if you are in US, your representation will be like this. Okay, you will talk in million and billion, right? This case also Java will support. Then what is the meaning? The meaning is you can have underscore anywhere you want. It won't restrict that. It is just for readability purpose. How do you want to separate? You can separate it, keep it. Where do you want to keep it? That doesn't care. Whenever it try to store this in memory, it will remove all underscore and store it. Okay, then the next question, shall I keep underscore in front of this number? Is it really making sense? Are we getting anything if we are adding underscore in front of the number? No, right? And one more is like, is Java supporting this or not? We will see. We are getting error. Like what is the error we are getting? Cannot find a symbol. It is considering this as a variable. Okay. So what we understood till now is like we can use underscore anywhere, only we can't use in front of the number, is what like we understood till now, right? Then we'll try. Then is it really allowing to store it at last? We'll see. Yeah, this is also really not making sense. It's really not helpful for our read or something, right? So this case, maybe usability really it is not helpful, but Java compiler allowing or not, we'll see. No, now also it is not allowing and it's showing this as illegal underscore. Okay. Then other case, maybe like other question also you may have, right? Consider if I am having this is double and I am storing this like that. We have already seen that like we can use it anywhere inside this one, right? But only prefix and suffix I can't use. Underscore is what we have seen till now. Okay, first let's run this. It is working. Then is it okay to use underscore before dot? Usability purpose, definitely it won't give any help. But Java, is it allowing or not? We'll see. Java, it is not allowing. It is giving illegal underscore. Okay, so this place also we are already using a dot to separate. It is actually a whole number, or it is having a precision value with dot, right? Left and right we are able to separate. But why do we really need underscore to separate that? It is not required, right? So usability purpose, it is not needed. That is why Java is allowing only to use underscore for readability, add it anywhere in a digit, instead prefix to the number or suffix to the number or before dot, Other than that, like Java is allowing us to have underscore anywhere in the number. Okay, now the readability part, what is the representation and what kind of literals we are able to use it with underscore we have seen, along with the different base value numbers how we can represent with Java in number system we have seen. Okay, we have seen this in the whole numbers. As I already told, this different representation can be used for byte, short, int and long. Similarly, float and double also being used with a different representation. This, if you want to use this binary, octal, decimal, hexadecimal, yeah, float and double also will support. Then next is a character. What is this? What we are what we are doing is like we are going to store a as a character in a variable. Character can have 2 bytes in memory. So what will have, it will 2 bytes means like it can have 0 to 65,535 can be stored in a character. For each and every number there is a associated letter which is stored in Unicode table that will be retrieved whenever it is needed. Instead, like it will be consider this as a number and stored in a system. Okay, this is what we have seen in a last video, right? Consider char a of a. So which means for a as a character, won't store this a as it is in computer. Instead, for this a, we will have associated number available in Unicode table, right? That number will be stored in computer system, and whenever it try to retrieve, it will take the number and it is considered this is a character. Then it will convert. It will map a particular character from it, and then it will give it to display or something if we try to print this. Okay, this is what happening behind the scenes. This case, what will happen, we'll see. This case, it is giving this as a. Okay, if we know what is the decimal value for a, right? It's 97. If we are keeping decimal value as 97, so it will store this 97 into memory. Then when we try to retrieve and try to print this, right, it will take 97 and identify this data type of this variable is character and convert, or it will map that particular number with the character or the letter what it is available in Unicode table. It will retrieve it and it will give it to display. Okay, same way for 97, right? Like the same way we can have it if we want to represent this as hexadecimal 0x61. If I keep this and run this, yeah, hexadecimal for 97 is 61. That is what it is taking and running. If I want to have this as binary, this is a binary representation for decimal value 97. Okay, so if I want to convert this in octal, 0141 is the octal representation for 97. Okay, so character also I can represent with hexadecimal, decimal, octal, binary, or as a character. And there is one more representation also available for character, that is Unicode representation. In Unicode representation, how basically the table has, right, Unicode value all available in hexadecimal format. For 97, the hexadecimal value is 61, which we have seen already, right? But it will only work if you are keeping 61 like this. This is /u will help Java compiler to identify this as Unicode number, and what is the exact value, it will try to map it in a Unicode table. Okay, so we need to keep it like this, then only it will take exactly what is the Unicode number and then it will map it in a Unicode table. You can see, right, like for this Unicode number the value is a in a Unicode table. That is why it is taken. Yes, we need to have 4 digit to represent the Unicode value, because 4 digit means hexadecimal, each digit will have 4 bits. Okay, so 4 digit means it's actually 2 bytes. So the 2 bytes representation is required. It's required for Unicode alone. If you have a doubt that will it work with G61 or not, we will see is it working or not, we'll see. It is giving compiler time error that illegal Unicode escape and empty character literal. These are two compiler error it is coming if you are giving like this. Okay, that is why whenever we want to represent the character in Unicode format, we should have a hexadecimal value, but that hexadecimal value should be represented in 2 bytes. Meaning, whatever we are representing, it should be in 2 bytes. If we keep this only, it will work. Okay, so 2 bytes means, as I already told, each digit can have 4 bits. Okay, 4 bits mean half the byte. If we have a 2 digit, 1 byte, 4 digit, 2 bytes. Okay, we need to have 4 digit to represent Unicode value in Java. As I already told, character is a single letter. Unicode table will have all single letter, and that respective Unicode value will be present. And if we want to uh, if you want to store, or like if you want to use some character, then we need to store this Unicode value in any representation as a Unicode number or hexadecimal or decimal, binary and octal, whatever it is. Or like even if we want to have a direct character itself, if we want to store in a variable, yeah, that is also possible, as like if you are giving a character as it is. Okay, but if you are keeping two letters and if you want to assign this to character, will it work or not? It won't work, right? Like basically the Unicode table doesn't have two letters, because like A have a separate Unicode number and T have a separate Unicode number, right? Like when we try to store it as it is, like it's actually a illegal statement, or it is not a Java statement. That is what a error, compiler error will throw. Along with that, like character means it will have a two only one letter. Open a quotes, expect compiler expects end quote, and similarly the other way. Okay, so we will get three compiler error. We'll see what and all it is coming. Yeah, it is showing this unclosed character literal, unclosed character literal. There are two error it will come for open close and end quotes. And then because like we have two, so what will happen, Java how it will take is like, okay, we have this quotes is available, then we have a character, then immediately it will expect a next quote. It is not available, that is why it's showing unclosed character return. Similarly, it is seeing this quotes is available, then a character, immediately it is not seeing any quotes is available, that is why we are getting unclosed character return. Then as I already told, it is not a Java statement, this error also it is coming. Okay, now we have seen what are all possible literals we can assign to different type of variables which we have seen, right? Next topic is type conversion. There are two type conversion is available in Java. One is implicit type conversion and then next one is explicit type conversion. Okay, basically the data type we will see what is the number of bytes it can hold on each and every data type, which we already seen, right? Like first one is byte can hold 1 bytes of data, short 2 bytes of data, integer 4 bytes of data, long 8 bytes of data, float 4 bytes, double 8 bytes, character 2 bytes. Boolean, it will actually differ for different JVM. One could have like 1 bit, one could have 1 byte, it may differ. Okay, that is why like I usually won't tell what is the default byte for Boolean. It may differ for different thing. Now we will see what is the implicit type conversion. Implicit type conversion, if I consider byte A is equal to 5, and next statement what we have is short B is equal to A. A is actually byte data type, right? But what we are doing, like we are assigning A to B, but B is a data type of short. Will it work or not? First we will see. Doesn't give any error. The compiler doesn't give any error, meaning that it is accepting. It is actually accepting byte data type assigned to short data type, right? Because byte data type can have 1 bytes in memory, right? Short can have 2 bytes in memory. Okay, so it can accommodate byte value also. That is why it will do implicit type conversion. It won't give any error. And similarly, short to int is also possible. We already know that. We can see that int c is equal to b. because integer can have 4 bytes in memory, short will have 2 bytes in memory. That is why we can keep short value in integer variable. And then similarly long d is equal to c. Possible. We can see like is it giving any error or not. No, it is properly compiling. So this is called implicit type conversion. Implicitly it is converting the type of variable. Okay, the next one, character. Character 2 bytes in memory, short is also 2 bytes in memory. Then I can interchange character and short, right? We'll see like is it working or not. We'll see. Character e is equal to b. Will it work or not? It is giving error. What is the error which we are getting is incompatible types, possible loss of precision from short to char. Why 5 can be achieved with 5 directly if I assign to char e, right? Will it give any error? No, it won't give any error, right? Like why then if I try to assign b, it's actually a short data type but it can have the data as 5. If I directly assign 5 to character data or character variable, it is actually accepting, but if I'm giving a short, it is not accepting. Why? Could be your question, right? I will explain. Short also 2 bytes in memory, character also 2 bytes in memory. That's true. That's true. But the problem is short is signed data type. Correct? Character is unsigned data type. Meaning character can hold 0 to 65,535, but it is splitted in short as signed numbers and unsigned numbers. That we already know, right? That is why the implicit conversion is not allowed between short and character. Okay, but how we can achieve this? Like it's actually 5. I can even store it into character, but why it is not allowing? There is a possibility to achieve this with explicit type conversion. What we can do is like we can have it like this. Like if we keep it like it will convert the value of p to character explicitly and store it in the variable e. This is called explicit type conversion. We'll see is it working or not. It is working. It's working, right? So short and character implicitly we can't convert because of like short is a signed data type. Signed data type means what is the minimum and maximum value of short? Minimum and maximum value of short is 32,760 minus 32,768 to 32,767, right? But character minimum and maximum value is 0 to 65,536. Even though both are having 2 bytes, both can store 2 bytes in memory, but the data range for short and int is short and character is different. That is why Java won't allow implicit type conversion between short and character. Okay, the next one is after long is 8 bytes in memory, but it can be implicitly converted into float even though float is 4 bytes in memory. Why? Float f is equal to d and double g is equal to f. It is allowing, it is not giving any error. You can ask how? Because long is 8 bytes in memory, right? Like how it is implicitly converted into floats, even though float can store 4 bytes in memory, right? Okay, I can take one example. Like if I am keeping instead of c, if I am keeping long dot max value. Maximum value of long can have 8 bytes in memory, right? 8 bytes in memory, right? First we will see it is actually allowing or not. Compiler is allowing. We will run this. What are we getting? The d we are storing a long maximum value, that is why it is printing like that. And when we store this as double, when we store the same value in float and from float to double, what it is happening is like since it's float, the representation of float is different. That is why it is actually storing it into computer system and allowing that 8 bytes to store in different representation in computer. Okay, but when it is giving exponential 18 with some value is got missed out, like after 2 7 7 2, like we are not seeing the 36 8 5 4 7 7 5 8 0 7, you meaning the representation is different. That is why it is, even though long is 8 bytes in memory, it is allowing Java compiler to implicit conversion and store it in float in different format. Hope we are clear what is implicit type conversion and what is explicit type conversion, and what are all types implicitly Java is allowing, that also we have seen, and why we are not able to do implicit type conversion between character and short, even though both are 2 bytes we have seen. And even though long is 8 bytes in memory, float is 4 bytes in memory, why Java is allowing long variable to be implicitly convert into float, that also we have seen because of the representation of floating point number, that we have seen already. Hope you understood everything clearly. What are all different possible literals available in Java, as well as what is implicit and explicit type conversion in Java. Okay, thanks for watching.